All right, welcome to the deep dive. Today we're going to really get into something that's, well, essential to all of us, our immune system. And you've sent in some pretty amazing material laying out how our bodies are like, uh, fortresses against all these invaders trying to attack us all the time.
Yeah, definitely. We've got a really solid base here with this handout from Dr. Rasha Eldeeb. It gives us, the immunity basics, the different ways it all works, and all the important players, like, all the cells and systems involved. Plus, we have some really useful visuals that break down acquired immunity and show us just what those B and T cells are up to. Oh, and also where all those critical lymphoid organs hang out.
Right. I mean, it's amazing how much is going on in there that we like don't even realize. So
Yeah.
our aim today is to make all of this stuff super clear for you. Like we want to pull out the coolest, the most important parts of how your immune system keeps you going, without getting bogged down in the overly complicated science bits.
Yeah, for sure.
So we're going to dive into all the layers of your body's defenses and the roles of all those different cells and organs. So to kick things off, maybe we should start with the absolute basics. What actually is immunity?
Okay, so in the simplest terms, immunity is like your body's own personal superpower. It's that amazing ability to fight off all the things that want to make you sick. We're talking about, bacteria, viruses, fungi, parasites, all that nasty stuff. And the reason you're not constantly, bedridden with some horrible illness is because your immune system is working around the clock, releasing these little protective molecules called antibodies.
Antibodies, right? Like little warriors going after the bad guys.
Exactly. They're going after those bad guys. Plus, they're launching all sorts of other defenses just to keep you in tip-top shape.
So we're going to be focusing on the two main ways your body does this, right? We've got innate immunity and we've got acquired immunity.
Exactly. Those are the big two.
Okay, so let's start with that first one, innate immunity. What's that all about?
Okay, so innate immunity is the defense system that you're basically born with. It's your natural, non-specific protection. You can think of it as like the standard security system that your body just comes equipped with right from the start.
So it's like always on guard duty. It just jumps into action right away. The second it senses, something foreign, something that's not supposed to be there, trying to cause problems.
You got it. Innate immunity kicks in super fast when it detects a potential threat. And a key thing to remember is that a big part of its job is basically trying to block those foreign particles from even getting inside your body in the first place. Like it's, guarding the gates, making sure nothing suspicious gets through.
So like having really good border control.
Exactly.
And Dr. Eldeeb's handout mentions some of these defenses that we already have, like those enzymes in our saliva that help break things down. And then there's the natural killer cells, which sound pretty intense.
Yeah, they mean business.
Our skin itself acts as a barrier. And then there are certain white blood cells called neutrophils.
Right. So all of those are components of your innate immune system that are just like ready to go from the moment you're born. They launch that initial response against anything that looks like an infection even before your body's ever encountered that specific germ before. It's a fast and general response ready to tackle anything, but it's important to remember that this is not the same as that longer-term, very specific acquired immunity that we'll be looking at later.
Got it. So innate is like that immediate general protection.
You got it.
Now, the handout also talks about 4 different lines of defense, different kinds of barriers that all fall under innate immunity.
Right.
So maybe we could break those down a bit. First up, the physical barriers. So obviously our skin is a big one, but it's more than just our skin.
Oh, definitely. I mean, your skin is like your first line of defense, literally. It's amazing at stopping tons of pathogens from getting in. But think about all those other, kind of vulnerable areas we have. Body hair, for example, plays a role. And those tiny little hair-like structures in your airways, the cilia, they're constantly sweeping away dust and microbes. Even our eyelashes help keep stuff out. And then our respiratory and digestive systems, they both have their own physical defenses as well.
It's incredible how much is going on without us realizing. And what about mucus? I mean, I always think of it as just a bit annoying, but it's actually doing something really important.
Oh, yeah, absolutely.
Yeah.
That sticky mucus in your nose and your ears, it's not just there to be gross. It actually traps those pathogens and stops them from going any deeper. It's a simple mechanism, but really effective.
It's like flypaper for germs.
Yeah. Exactly.
Okay, so next up we've got physiological barriers. That sounds a bit more internal.
Yeah, you could think of this as more of an internal chemical defense.
Okay.
Think about the hydrochloric acid in your stomach.
Mm.
It's super acidic, strong enough to kill off most of the germs that come in with your food. Talk about a hostile environment.
Yeah, it's definitely not a place you want to be if you're a germ.
Nope, not at all.
And what about saliva and tears? I mean, I never would have thought of those as like part of the immune system.
Oh, they're definitely part of the team.
Uh-huh.
Both saliva and tears contain antibiotic properties that actively prevent those pathogens from growing. It's like this continuous, gentle wash, but with a built-in germ-fighting agent.
That's pretty neat. So even if some of those sneaky pathogens make it past those first two barriers,
Yeah.
there's still cellular barriers waiting for them. This is where our white blood cells come in, right? Those leukocytes.
Exactly. If those pathogens get through the first two lines of defense, then the cellular barrier steps up.
Hmm.
This is all about the different types of white blood cells that are constantly circulating in your blood and hanging out in your tissues, patrolling and keeping an eye on things.
Right.
Some of the key players here are the neutrophils, the lymphocytes, the basophils, the eosinophils, and the monocytes.
Wow, that's a lot of panophils.
I know, right? And each one has slightly different jobs, but they're all about identifying and taking care of threats.
Got it. Okay, so last but not least, we've got the cytokine barriers.
Right.
This sounds a little bit more, I don't know, high-tech, like it's about cells communicating and warning each other about danger.
Yeah, that's a great way to think about it. So, for example, when a cell gets infected by a virus, it can release these proteins called interferons. You can think of them as emergency signals.
Okay.
Interferons coat that infected cell, but they also send out warnings to all the neighboring cells, making them more resistant to infection. It's like a super localized early warning system.
So the infected cell is basically yelling out, warning, warning.
Exactly. Lockdown, lockdown.
Okay, so that's how the innate system works. Now, maybe we should talk a little bit about the key cells involved in this immediate response. So phagocytes, those are like the garbage collectors of the immune system, right?
Yep. That's a good way to think about it. They're constantly patrolling, looking for anything that doesn't belong. When they find something suspicious, they just gobble it up, engulf it, and basically digest it. Macrophages are a really important type of phagocyte.
Right.
And they're special because they can actually leave the bloodstream and move into the tissues.
So they can move across those circulatory system walls. They're pretty mobile then.
Totally. And when they get to an infection site, they release these signaling molecules called cytokines.
Cytokines, aren't those the chemical messengers we were talking about earlier?
The very same. And these cytokines basically act like an SOS. They attract other immune cells to the area to help fight off the infection. So macrophages are kind of like the scouts, but they also call in the reinforcements.
That's pretty cool. What about mast cells? I usually associate those with like allergies and things like that.
Yeah, you're right. They are involved in allergic reactions. But they also play a super important role in wound healing and defending against certain infections. They're kind of like the body's all-purpose responders. They handle injuries and invasions, all in a day's work.
Wow, they're busy. And then we have neutrophils. Dr. Eldeeb's handout mentions that they contain these toxic granules. They sound kind of scary.
Yeah, neutrophils are definitely not messing around. They're full of these granules that have all sorts of potent toxic substances. When they encounter a pathogen, they just release all this stuff and, basically kill the invader on the spot. They're like the heavy artillery of the innate system.
So eosinophils and basophils, they also seem to be kind of specialized in going after particular threats.
Right. So eosinophils have these highly toxic proteins that are especially good at fighting off larger invaders like bacteria and parasites.
Yeah.
And basophils, they go after those multicellular parasites, and much like the mast cells, they release histamine. That's a chemical that's really important in inflammation.
Right, histamine, that's what gets us all sniffly and itchy.
Exactly.
Okay, what about natural killer cells? I mean, the name itself sounds pretty intimidating. Are these like the body's elite assassins?
In a way, yeah. Natural killer cells don't go directly after the pathogens themselves. Instead, what they do is they stop the spread of infection by destroying infected host cells.
Host cells.
Yeah, those are the cells in your own body that have been taken over by, say, a virus or some other intracellular pathogen. So it's like a strategic move, Sacrifice the infected cell to protect all the healthy ones.
So like a controlled demolition.
Yeah, exactly. Better to lose one than risk the whole building.
Makes sense. And finally, you've got dendritic cells.
Yes.
The handout says that these act as messengers. What does that mean?
Yeah, that's a perfect way to describe them. Dendritic cells are found in tissues that are, kind of the first points of contact for infections, like your skin and your mucous membranes.
Okay.
They're constantly sampling their environment, And if they detect an infection, they grab onto those foreign markers, the antigens, and then they present them to the rest of the immune system.
So they're showing the adaptive immune response, what to look for, what the enemy looks like.
Exactly. They're like, hey guys, this is the bad guy. Be on the lookout for this one.
So the innate system is kind of like the first responders, always on patrol, with all these different specialists handling those immediate threats.
Yeah, definitely.
And then they're even putting out the call for the more specialized units to come in, which brings us to acquired immunity.
Right.
This is the system that developed over time as we encountered different threats, different pathogens.
Exactly. Acquired immunity, also known as adaptive immunity, isn't something you're born with. Well, not entirely. It develops throughout your life as your immune system learns to recognize and target the specific pathogens you come across.
So it's unlike the innate system, which is kind of general. This is much more precise, like a tailor-made response for a specific invader.
That's a great way to put it. It's tailored, specific, and it only develops after birth, hence the name acquired.
Right, acquired. So the specificity comes from its ability to target those particular pathogens using very specific antibodies or specialized lymphocytes.
Right.
And the main goal here is to, get over the current infection, but also to remember those invaders so next time they come around, the body's ready for them.
Exactly. Prevention is key.
The handout describes it as an advanced lymphatic defense system, and it's got this incredible ability to recognize our own body cells and not attack them.
Yeah, that's really crucial. That non-self recognition is fundamental to how it all works.
Okay, now the visual aid you mentioned breaks down acquired immunity into two main types, active and passive.
Right.
Let's start with active immunity. What's that all about?
Active immunity happens when your body responds directly to a foreign antigen that's inside your system. So that's the antibody generator.
Okay.
The important thing here is that your body's actively involved in building up its defenses.
And this is how the body develops a memory of past infections, right?
Exactly. Once your body has gone through that active immune response, it keeps a memory of that encounter.
Okay.
This type of immunity can happen either through direct contact with a pathogen or its antigens, and that then triggers your body to start producing its own antibodies tailor-made for that specific threat.
So there are two ways this can happen, right? There's natural active immunity, and then there's artificial. So the natural way is just like getting sick with something and then recovering.
Right, exactly. So when you're exposed to a pathogen for the first time, your immune system launches what we call a primary response. After you recover, your body hangs on to some of those specific antibodies and specialized immune cells, and that provides protection against future infections by the same pathogen.
So like, you only get the measles once.
Precisely.
And then artificial active immunity is what we get from vaccines, right?
Yep, that's the one. We're basically introducing something that triggers that antibody production without actually causing the full-blown illness.
So vaccines contain those weakened or inactive forms of pathogen,
Right.
or just specific parts of them, the antigens.
That's right, and that's enough to get your immune system going. It thinks it's being attacked, so it starts making those antibodies and memory cells, even though you don't actually get sick. It's like a sneak preview of the real thing.
Genius. Okay, so what about passive immunity? We see in this flowchart that it's also divided into natural and artificial.
Right. Passive immunity is different because with this one, you're receiving ready-made antibodies from somewhere else.
So your body's not actually making them itself.
Exactly. Your body isn't doing the work this time. It's like borrowing someone else's immune protection. And because of that, the initial immune response is often weaker. So passive immunity offers immediate, but usually short-term help. It's like a temporary shield.
So it's shorter term than active immunity because the body isn't building up that long-lasting memory.
Right. Passive immunity is all about immediate protection, so it acts quickly. But because it doesn't lead to the creation of your own memory cells, that protection eventually fades.
Okay, got it. So natural passive immunity would be like when a baby gets those antibodies from its mother, either in the womb or through breast milk.
Yes, exactly. During pregnancy, some antibodies can cross the placenta and go from the mother to the baby, and that gives the baby crucial protection in those first few months. And then breast milk is full of antibodies that help protect the newborn from all the infections they're going to encounter as they, discover the world.
That's amazing. And then artificial passive immunity would be something like getting an injection of antibodies, like the rabies immunoglobulin that Dr. Eldeeb mentioned.
Right. So if someone is exposed to rabies, for example, they might get an injection of antibodies that are specifically designed to target that virus. That gives them immediate protection, even though it's temporary, until hopefully their own immune system can kick in and take over.
That's pretty incredible. So, just to recap, active immunity is your body doing the work and remembering, and passive immunity is like borrowing those ready-made defenses for immediate but shorter-term protection.
Perfect summary.
Now, Dr. Eldeeb's handout also lists some key features of acquired immunity:
Right.
specificity, diversity, the ability to differentiate self from non-self, and memory. Yeah.
We've already talked about some of these, but maybe we could go into a bit more detail.
Sure. So the specificity is just amazing. The acquired immune system can tell the difference between all these different pathogens, even ones that are very similar, and it can mount a targeted response against each one. And the diversity is also mind-blowing. Your body can potentially recognize and respond to basically an unlimited number of different pathogens, from those tiny little viruses to the much larger parasites.
It's incredible. And that ability to tell self from non-self, that's what stops the immune system from attacking our own healthy cells.
Exactly. That's absolutely crucial. And when that system malfunctions, that's when we see what we call autoimmune diseases, which we'll talk about briefly in a bit.
Okay.
And then memory. That's what makes acquired immunity so powerful in the long run. The system remembers those past infections and the antibodies it made, and then if you encounter that same pathogen again, it can launch a much faster, much stronger response.
It's like it's got a wanted poster ready to go.
Okay, so let's talk about the key cells that are involved in acquired immunity. We've got the B cells and the T cells, and that visual aid summarizes them really well. B cells attack invaders outside the cells, and the T cells attack infected cells.
Yep, that's the simplest way to remember what they do.
So B cells mature in the bone marrow, and they're the main players in humoral immunity.
Right, so B cells get activated when they encounter those foreign agents, the antigens. You can think of an antigen as like a unique name tag on the surface of a germ.
Okay.
It's how the immune system recognizes what it's dealing with.
So when a B cell sees its specific antigen, it basically gears up to produce those targeted antibodies.
Exactly. When a B cell recognizes its matching antigen, it changes into these specialized cells called plasma cells.
Plasma cells.
And these plasma cells are like tiny little antibody factories. They're constantly producing and releasing antibodies that are specifically designed to bind to that particular antigen.
So the antibodies are like those guided missiles
Yeah.
locking onto the surface of the invader and marking it for destruction.
You got it. And then these antibodies circulate all over your body, looking for their target antigens. That binding can either directly neutralize the pathogen, stopping it from infecting cells, or it can flag it for destruction by other immune cells.
Okay.
Now, because B cells and antibodies mainly work in the fluids of the body, the humors, this part of acquired immunity is called humoral immunity.
Okay, that makes sense. So B cells and antibodies are defending us against those external threats, the stuff that's floating around outside our cells.
Exactly.
What about T cells? They develop in the thymus, right?
Yep, that's where they go to school. T cells start in the bone marrow, just like B cells, but then they go to the thymus gland to mature. And in the thymus, they develop into different types of T cells. There are the helper T cells, the cytotoxic T cells, and the regulatory T cells. And then once they're ready, they get released into the bloodstream.
And those helper T cells are often called the orchestrators because they're directing the whole immune response.
Yeah, that's a great way to think about them. When a helper T cell encounters an antigen that it recognizes, and that's often presented to it by those dendritic cells we talked about, it releases those signaling molecules, the cytokines. And those cytokines play a crucial role in stimulating the B cells to turn into those antibody-producing plasma cells.
All right.
So helper T cells are essential for getting the humoral immune response going.
They're like the generals?
Yeah, the strategists.
Okay, so what about cytotoxic T cells? They're the ones that go after the infected cells directly.
Right. Cytotoxic T cells directly attack and destroy any cells that have been infected by viruses or other intracellular pathogens, and also any cells that have become cancerous.
Oh, wow.
They do this by releasing toxic substances that cause the infected cell to self-destruct.
So it's like a programmed cell death.
Exactly. Apoptosis. It's a controlled demolition.
And then regulatory T cells are like the peacekeepers, making sure that the immune response doesn't go overboard and attack our own tissues.
That's right. They're essential for maintaining balance. They control and regulate those immune reactions, so they prevent excessive inflammation and the development of autoimmune disorders. So because T cells act directly on infected cells or foreign cells, The immunity they're responsible for is called cell-mediated immunity.
Okay, so we've got humoral immunity with the B cells and antibodies handling the external threats, and cell-mediated immunity with the T cells taking care of those internal problems, the stuff going on inside our cells.
Exactly. Two sides of the same coin.
The handout also mentions how these two responses are not totally separate. They actually work together.
Right. They're a team. It's not as simple as, B cells do this and T cells do that. It's much more of a coordinated effort. So when a B cell encounters an antigen, it doesn't just immediately start making tons of antibodies. It also takes in that antigen and presents little pieces of it on its surface.
So it's like it's captured a piece of the enemy and it's showing it off?
Exactly. It's like a wanted poster. And then if the helper T cell recognizes that poster, it releases cytokines. And those cytokines give the B cell the signal to start multiplying and differentiating into more of those antibody-making plasma cells and also into memory B cells.
So it's a multi-step attack, very coordinated.
It's a complex dance.
And meanwhile, the cytotoxic T cells are doing their own thing, going in and eliminating those infected cells directly.
Exactly. A two-pronged attack. And, T cells are also really important in recognizing foreign tissue, which is why transplant patients have to take those immunosuppressant drugs.
Right.
Because their T cells see that transplanted organ as non-self and would attack it.
So that's a really clear example of that self versus non-self feature in action.
It is.
Okay, now let's talk a little bit about autoimmunity. This is what happens when that non-self recognition goes wrong.
Right. Autoimmunity happens when the immune system makes a mistake. It identifies the body's own healthy tissues as foreign invaders and starts attacking them.
And the handout gives the example of type 1 diabetes.
Yeah, that's a classic example. In type 1 diabetes, the immune system goes after the beta cells in the pancreas, the ones that make insulin. So it's basically the body's own defense system turning against itself.
That's really scary. It just shows you how important it is that this whole system is working properly.
Absolutely. It's a delicate balance.
Okay, so let's move on to vaccines. We talked about how they create artificial active immunity, but maybe we can break down exactly what they are.
Sure. So vaccines contain those antigens, those unique markers from the pathogens that cause disease. The handout uses the smallpox vaccine as an example.
Right.
So it contained antigens from the smallpox virus.
So by putting those antigens into the body, you're basically giving the immune system a preview of the real threat.
Exactly. It's like a training exercise. It thinks it's being attacked and starts making those specific antibodies and memory cells, but without actually getting sick.
So if the person ever encounters the real virus, their system is ready to go.
Exactly. It can respond much faster and more effectively.
Right.
So vaccination triggers that artificially acquired active immunity. It's like giving your immune system a head start.
Amazing. And immunization is just the overall process of giving someone that protection.
Right. It's the act of administering the vaccine.
Okay, so the immune system is just this incredibly complex and adaptable network of defense. It's not just one thing. It's a whole army of cells and tissues and organs all working together. And immunology is the study of this whole system, right?
That's right. Immunity is the ability to resist those pathogens and stay healthy. And the immune system is everything that makes that possible.
Yeah.
It's involved in so much more than just fighting infections, though. It plays a role in allergies, autoimmunity, and even in organ transplantation.
So those white blood cells, the leukocytes, are like the frontline soldiers.
They are.
But then the handout also talks about lymphoid organs, and the diagram shows a bunch of them all over the body.
Right.
What do those lymphoid organs do?
Lymphoid organs are basically the key locations for all that immune activity. They're the organs involved in defending against those infection-causing pathogens and even tumors.
Okay.
The diagram shows several of them, like the bone marrow, the lymph nodes, which are all over the place, the lymphatic vessels that connect them, the thymus, the spleen, the tonsils and adenoids, the appendix, and Peyer's patches.
Wow, there are a lot of them.
There are, and you can think of them as like strategic hubs for the immune system.
So these are the places where immune cells are either made, or they mature, or they gather to coordinate their attacks.
Exactly. They're the sites where lymphocytes are produced, they mature, and they proliferate.
Proliferate, meaning they multiply.
Exactly. And we can categorize them based on their stage of development and their function.
So we've got primary, secondary, and tertiary lymphoid organs.
You got it.
Let's start with the primary ones. We've got the thymus and the bone marrow.
Right. So those primary lymphoid organs, also called essential lymphoid organs, are the places where lymphocytes are made and go through their initial development.
Okay.
The bone marrow is where all the blood cells come from, including all those lymphocytes from stem cells. And then the thymus is where the T cells go for their specific training.
Right.
So these are the sites where those key players of the adaptive immune system are born and trained.
So the bone marrow is like the central command, and the thymus is like the specialized boot camp for the T cells.
Perfect analogy.
What about the secondary lymphoid organs? The spleen, the tonsils, the lymph nodes?
So those secondary lymphoid organs, they're also called the peripheral lymphoid organs.
Okay.
And they're where those mature lymphocytes encounter antigens for the first time and where those adaptive immune responses are usually initiated. So you can think of them as the battlegrounds. The places where the immune cells meet up with the pathogens they're meant to fight. For example, the lymph nodes are strategically placed all over the body along the lymphatic vessels.
Right.
They filter the lymph fluid, trap any pathogens, and that provides a place for lymphocytes to encounter them. The spleen filters the blood, gets rid of damaged red blood cells, and it's also a site for immune responses against blood-borne pathogens.
Oh, okay.
The tonsils and adenoids protect the entry points to your respiratory and digestive systems. They're like local security. And then the appendix and Peyer's patches, they monitor the gut, which is constantly interacting with the outside world.
So those secondary organs are where those immune responses actually happen.
Right.
And finally, we have the tertiary lymphoid organs.
Right. So these are a little different. They don't usually have a ton of lymphocytes, but they can become really important when there's inflammation.
Okay.
They can help with those localized and sustained immune responses.
It's just amazing how all of this is going on inside of us all the time.
It really is. The body is just incredible.
Well, this has been a really incredible deep dive into your sources on immunity. We've covered so much. We've looked at the two main types of immunity, the innate system with all its barriers and specialized cells, and the acquired system, which is all about that incredible teamwork between the B and T cells.
Right.
We talk about how vaccines work and the roles of all those different lymphoid organs.
Yeah, it's been a really comprehensive overview.
Yeah.
From those immediate defenses that you're born with to those super specific, targeted responses that develop throughout your life.
And it makes you wonder, what else is going on in there that we haven't even discovered yet.
I know, right? There's so much more to learn.
Thanks for joining us for this deep dive.
My pleasure.